Let's talk about prime numbers, factors, and reducing a fraction to lowest terms. First, what is a prime number? Prime number is a whole number greater than 1 that has exactly 2 divisors, itself and 1, meaning only 1 and itself go into it. So 1 is not a prime number because it has to be bigger than 1. 2 is a prime number. 3 is a prime number. But 4 is not a prime number because 2 divides 4. 5 is a prime, but 6 is not because 2 goes into 6 and 3 goes into 6. 7 is a prime, but 8 is not. 9 is not. 10, 5 and 2 go into 10. 12 is not. 14, 15, 16 are not, but 17 is a prime. 18 is not, but 19 is a prime. 20, 21, no. 22, even. 23 is a prime. 24, 25, 26, 27, 28. 29 is a prime, but 30 is not. 31, you might be beginning to wonder how many prime numbers are there? And the answer is no one really knows. They get quite large, and people spend their entire math career studying prime numbers. Let's talk about vocabulary. You'll recall from before, factors are things that we multiply, and the result of the multiplication is the product. And since 3 is a prime and 5 is a prime, then 3 and 5 are the prime factors of 15. So you would say the prime factors of 15 are 3 and 5. Or you can also call this the prime factorization, which is just writing out a number as a product of its prime factors. Let's practice with a few examples. So 21 is a composite number. If you wanted to write its prime factorization, you'd say what goes into 21, and that would be 3 times 7. And this is the prime factorization because 3 is a prime and 7 is a prime. What about 35? Well, 35 is 5 times 7. And because 5 is a prime and 7 is a prime, that's the prime factorization. 30 is 6 times 5. So 6 is a factor of 30 because it divides 30 evenly. But 6 is not a prime, so this is not a prime factorization. You'd have to keep breaking it down. So we break down the 6. 5 is a prime, so you can just bring that down. So you can rewrite this as 2 times 3 times 5. And now that we have all primes, this is the prime factorization. It does not matter what order you write the prime factors because multiplication is commutative. You can multiply in any order that you wish. I just think it's more elegant if you write them in ascending order. Let's write the prime factorization of 18. And you're probably thinking, how do I start? I could do 2 times 9 or 3 times 6. And the answer is, it doesn't matter how you start. So if you started with 2 times 9, you would go, yeah, 2 is a prime, but 9 is not. So you bring down the 2 and keep factoring. So you have 2 times 3 times 3. But if you had started with 3 times 6, you would say, yes, 3 is a prime, but 6 is not. I'll bring down the 3 and break down the 6. And then you would check, is 2 times 3 times 3 the same thing as 3 times 2 times 3? And the answer would be yes. And then if you wanted to write it in the most elegant possible way, and I know you do, that's the goal of every mathematician, to make their answer as elegant as possible. If you have a prime that's repeated, you can write it with an exponent. Let's write the prime factorization of 72. So it doesn't matter how you start. You could do 2 times 36, or I'm going to start with 8 times 9. And then you just check. Is 8 a prime? No, so let's break it down. 8 is 2 times 4. Is 9 a prime? No, so we break it down. And then 2 is a prime, but 4 is not. Let's bring down the 2, but break down the 4. 3 is a prime, and 3 is a prime. We get 2 times 2 times 2 times 3 times 3. And you just check that every one of those is a prime. And you can also check by multiplying them all out in a calculator. See if you get 72. And then, because you want your math to be elegant, let's write it with exponents. 2 multiplied by itself 3 times is 2 to the third. 3 times 3 is 3 squared. So if you're breaking down a number that's in your times tables, then you just use your times table. But what about bigger numbers? You can use the divisibility rules to break down bigger numbers. So for example, divisibility by 2, a number is divisible by 2 if it is even. Remember that even numbers end with 0, 2, 4, 6, or 8. So you could say, write the prime factorization of 38. Well, it ends with an 8, so it's even. That means that 2 goes into it. You divide 38 by 2, and you get 2 times 19. And you're done, because 2 is a prime, and 19 is a prime. The rule for 5, if a number ends with 0 or 5, it is divisible by 5. So if you're trying to write the prime factorization of 85, you'd say, oh, it ends with a 5. You divide it by 5. And then you check. 5 is a prime, and 17 is a prime. So 5 times 17 is the prime factorization of 85. divisibility by 3, if the sum of the digits of a number are divisible by 3, then the number is divisible by 3. What does that mean? So we look at 51, and initially you might think it's prime. But if you add the digits, you get 6, and 3 goes into 6. So you can divide 51 by 3. So 51 is 3 times 17. And then you check 3 is a prime and 17 is a prime. So I can use those divisibility rules and factoring rules to do reducing of fractions. And the main thing we're going to use is that any fraction where the numerator is equal to the denominator is equal to 1. And 1 times any number gives you the same number. So reducing fractions is another way of writing equivalent fractions. Let's do some examples. So let's take the fraction 10 over 15 and reduce it to lowest terms. So you would write the factors of 10, 2 times 5, and you would write the factors of 15, 3 times 5. So this is basically 2/3 times 1, because 5 over 5 equals 1. So our equivalent fraction is 2/3. Let's do another. Let's reduce 21 over 35. Well, what goes into 21? 3 times 7. What goes into 35? 5 times 7. So this is basically 3/5 times 1, because 7 over 7 is equal to 1. Let's reduce 30 over 70. Now, some people like to say they're canceling zeros, and that's not really correct, because 30 is 3 times 10, and 70 is 7 times 10. So we're just rewriting 3 over 10 times 1, which is 3/7. So you can cross out the zeros, but I want you to remember that you're reducing because 10 over 10 equals 1. Now, if you have numbers that are not in the times tables, you can try your divisibility rules. So 51 is not even, 2 does not go into it. And you try, does 3 go into it? 5 plus 1 is 6, so 3 goes into it. With 85, you would try 2. 2 does not go into it because it's odd. 8 plus 5 makes 13, so 3 does not go into it. But it does end with a 5, so 5 goes into it. (17 over 17 equals 1, and you get 3/5. All right, we have 14 over 7. 14 is 2 times 7, and 7 is a prime, but you could write it as 1 times 7. 7 over 7 is equal to 1. So we're left with 2 over 1. And remember, that's the same thing as 2 divided by 1, which is 2. Let's reduce this fraction. Now 3 is already a prime number, so you can just leave it alone. 15 is 3 times 5. So 3 over 3 is equal to 1. And you might be a little freaked out because there's nothing left in the numerator. So I like to just write that that's 3 times 1. 3 over 3 is equal to 1. And your answer is 1 over 5. So any number that's divided by 1 is the same number. But 1 divided by 5 is still going to be 1/5. So if you have a 1 left in the numerator, it has to stay. If you have a 1 in the denominator, you can write that as a whole number.